Good evening, everybody. Let us revise tangency and then we'll solve remaining sums. Actually, in tangency, we consider 4 points. When I say tangency means tangent to any curve. In the first part, we obtain equation of tangent to the curve at a point Px1, y1 on the curve. Actually, when I say tangent, that indicates that point lies on the curve, because if point lies inside the curve, no tangent. If point lies outside the curve, two real distinct tangents. And if point lies on the curve, then only one tangent can be drawn. In the second part, we find the condition that line with slope m is tangent to the curve. See, if this is a curve, then every line with slope m will not be tangent. Suppose this is the line whose slope is m. Clearly it is not a tangent. But there are infinitely many lines having this slope. Note that this line is tangent, right? So slope is given, means y equal to mx is fixed. What is different is c. So when we say find the condition that line y equal to mx plus c may be tangent to the curve, means we have to find restriction on c, and obviously that will be in terms of m and parameters which are there in the equation of curve. Okay, in the third part we show that in general two tangents can be drawn to the curve from a point x1 y1 in the same plane. Use common sense. For that you should obtain quadratic equation in M. Now there are three possibilities. Roots of quadratic equation in M, say m1 m2, which are the slopes of the two tangents, may be real and distinct. So two tangents distinct can be drawn. The roots m1 m2 of this quadratic equation in M, which represents slopes of the two tangents, can be equal. If discriminant is 0, then yes, roots are real and equal. So two coincident tangents, that is one tangent, so point lies on the curve. And third possibility, discriminant less than 0, roots are imaginary, so no real tangent can be drawn. Suppose point is here, can we draw a tangent? No. So we do get a quadratic equation, but its roots will be imaginary. Fourth part, suppose two distinct tangents can be drawn. It is likely that tangents are at right angles. So in the fourth part, we are interested in obtaining locus of points, tangent from which to the curve are at right angles. Okay. Now we discuss these four parts to circle. Circle will be followed by parabola, ellipse and hyperbola. Every time I will explain this part. So by the end of this circle and conics, I'm sure you will be confident about at least tangency. Okay. I think I have already explained T notation also. T means tangent. That is very simple. Right, or in the equation of curve, I can say in the equation of curve, replace x square by xx1, y square by yy1, 2x by x plus x1, 2y by y plus y1, keep constant term unchanged. You get equation of tangent. For example, consider standard circle x square plus y square equal to a square. What will be equation of tangent to this circle at a point x1 y1 on it? This can be written directly. Replace x square by xx1, y square by y1, keep constant term unchanged. That's it. So this is equation of tangent to standard circle at a point x1 y1 on the circle. Now that point x1 y1 can also be taken as a cos theta, a sin theta. Okay, so in that case what will be the equation? X into a cos theta plus y into a sin theta equal to a square. One a gets cancelled, So x cos theta plus y sin theta equal to a. This is what? This is equation of tangent to standard circle only, but at a point P of theta on the circle. Okay. Suppose we consider general circle. See, that equation can be written as x square plus y square plus 2gx. But 2gx is g into 2x. 2fy is f into 2y plus c equal to 0. Right? Now, as per this notation, what is the equation of tangent? Xx1 plus yy1 plus g into x plus x1 plus f y plus y1 plus c equal to 0. Yes. But if you are asked to prove this, you cannot use this analogy. You have to use the fact that radius through point of contact is perpendicular to tangent. I have already explained the proof. Get the slope of radius, then get the slope of tangent. Tangent passes through x1, y1 and so on. Is that clear? So this is about the uh, tangency to any curve and then tangency to circle. We have just discussed the first part. Let us solve sum number 5 from exercise 6.3. Find the equation of the tangent to the circle x square plus y square minus 4x plus 3y plus 2 equal to 0 at the point 4 minus 2. Now for this circle, actually you should write compare this with and so on. I have directly written 2g is minus 4, so g is minus 2. 2f3, so f3 by 2, c is 2. Now what is tangent at x1, y1? This is the equation, but tangent is drawn at 4 minus 2. So substitute the values, simplify to get the answer as 4x minus y minus 18 equal to 0. How will you verify this? As 4 minus 2 lies on these coordinates should satisfy the equation. Check 16 plus 2, 18 minus 18, 0. Yes. Let us discuss geometrical interpretation of derivative. We know that what is tangent? Tangent is limiting position of secant. Consider the curve whose equation is y equal to fx. Okay. P and Q are 2 points on the curve. I haven't shown coordinate axis. P is x coordinate is a, so it will be y coordinate f of a. Q has x coordinate a plus h. So if I draw these two perpendicular axes x and y, then this much is h. Okay. X coordinate of q is a plus h. So it will be y coordinate f of a plus h. Simple. Now, what will be the slope of secant PQ? Y2 minus y1, that is f of a plus h minus f of a upon x2 minus x1, that is a plus h minus a. So I will directly write h. Now, limiting position of secant is tangent at P. Suppose this is the first position Q. As Q approaches P, but strictly along the curve. Suppose this is next position Q dash. Then this is again next position and so on. So when P and Q coincide, so at that time I can say that when P and Q coincide, this is nothing but tangent at P. Okay. But you will appreciate this, that as Q approaches P, H, this change approaches 0. So can I say that limiting value of the slope of secant as h tends to 0 is nothing but slope of tangent, and therefore I can say that slope of tangent at P is nothing but limit h tends to 0 of this. But you should know from the first principle this is f dash of a, and therefore conclusion is f dash of a, that is dy dx at x equal to a, represents slope of tangent to the curve y equal to fx at a point x equal to a on the curve. What will be the equation of that tangent? Tangent is drawn at a f of a and slope of tangent is f dash of a. So equation is y minus f of a equal to slope f dash of a into x minus a. Simple. Okay. Now normal is perpendicular to tangent at this point. So this is normal. What will be the equation of normal? Normal passes through the same point, but it will have slope what? Minus 1 upon f dash of a. Why? Product of slopes of two perpendicular lines is minus 1. See, their product is minus 1. So this is equation of normal. Actually, we can verify this for line also. 3x minus 11y equal to 7. Find out derivative. Derivative of 3x is 3 minus 11. What is derivative of y? dy dx. What is derivative of 7? 0. So what is dy dx? 3 upon 11. Actually, this is not a curve, but still we can use this logic. Is slope of this line 3 upon 11? Yes. Slope is negative coefficient of x upon coefficient of y. So we have verified this result. Is that clear? So this is the geometrical interpretation of derivative. So derivative represents slope of tangent to the curve at a point on the curve. Now why I'm giving stress on this on the curve, at a point on the curve? Because a point doesn't lie on the curve, it doesn't belong to the domain of the function. So how can we find derivative at that point? Not only that, suppose this is curve, if point lies inside, then no tangent can be drawn. But if point lies outside, then not one, but two tangents can be drawn. I hope that this is clear to you. Okay. Second part is physical significance of derivative. I already explained this, that what is the physical significance of derivative? dy dx gives rate of change of y, rate of change of y with respect to x. That's it. This is physical significance. So if s equal to f of t is displacement function, then ds dt is nothing but rate of change of displacement with respect to time. It is called as velocity. And what is rate of change of velocity with respect to time? Rate of change means derivative. So dv dt gives the rate of change of velocity with respect to time. So it is nothing but acceleration. Okay. Now, this method is not used. Which method? Geometrical interpretation of derivative. But we can use this method to get the equation of tangent to the circle. See, this is the center of standard circle, which is at origin. Tangent is drawn at this point, say x1 y1. Now x square plus y square equal to a square. Find out derivative. Derivative of x square is 2x. What is derivative of y square? 2y dy dx, which is 0. See, this is the reason why they haven't used this method. Because this is not from 11 standard syllabus. Y square. I have already explained to you chain rule. What is derivative of y square? 2y into derivative of y, which is dy dx. But chain rule is introduced in 12 standard syllabus, and that is why they have used which method? Slope of suppose this is p, slope of op is y1 upon x1, so slope of tangent is negative reciprocal and so on. But I think few students will be able to understand this. Remember, this method you are not supposed to use in exam, because what I am explaining is from 12 standard syllabus. You are not supposed to know that. But I have already explained chain rule, and there are few students from our class who have done integration also, so they will understand this. Now simplify. So what is dy dx? It is minus x upon y. Yes, this is slope of tangent drawn at which point? X1 y1. So slope of tangent is minus x1 upon y1. Yesterday we used different method. What is slope of OP? y1 upon x1. So what is slope of tangent? Negative reciprocal. So minus 1 upon this. Yes, same as this. Right? The rest part is the same. Now we discuss the second point in tangency to find the condition that line y equal to mx plus c may be tangent to the standard circle. That is to obtain equation of tangent. But note that in this case, I should say equations of tangents to standard circle. And what is the speciality of those tangents? Slope is m. See, I can draw this. This is circle. Okay. Suppose this is one tangent to slope is m. Note that there is one more tangent having the same slope. So we expect how many? Two values of c for the same value of m. I hope you understood this. Okay. Y equal to mx plus c is tangent to the standard circle. But what is equation of tangent to standard circle? We have done this. Xx1 plus yy1 equal to a square. So this equation and this equation, they represent the same line. If two equations represent the same line, their coefficients are comparable. I'll repeat this. But for that, you should write both equations in that form. Means what? Y equal to mx plus c. So I rearrange the terms to get yy1 equal to minus xx1 plus a square. Now this equation and this equation, they represent the same line. I'll take simple example so that you will understand this. First line is x equal to 2y minus 1. Second is 2x minus 4y. Okay. Uh, plus 2 equal to 0. Are these two lines different? No, they are the same. So I can say if two lines are the same, don't say that coefficient of x is the same, coefficient of y is the same, constant term is the same. No, they are comparable. For that, I will write second equation also as 2x equal to what? 4y minus 2. See, what is coefficient of x? 1. 1 upon 2 equal to 2 upon 4 equal to minus 1 upon minus 2. We have already used this at least 2 to 3 times. If two equations represent the same thing, then their coefficients are comparable, means proportional. Okay? Yes. Y equal to mx plus c is tangent to the circle, but tangent to the circle is xx1 plus yy1 equal to a square. That is yy1 equal to minus xx1 plus a square. Two equations are representing the same line. So coefficients are comparable. What is coefficient of y? y1, here it is 1. So y1 upon 1 equal to coefficient of x minus x1 upon here coefficient of x m equal to a square upon c. Now second and third gives me x1 equal to minus a square m upon c. And what is y1? A square upon c. But x1, y1, this point lies on the circle. Why? Because this is equation of tangent to the circle at a point x1, y1 on the circle. So coordinates will satisfy the equation. Means what? X1 square plus y1 square is nothing but a square. Substitute. What is x1? Minus a square m by c. Its square I will write directly. A raised to 4 m square upon c square. Y1 square a raised to 4 upon c square equal to a square. See, we are interested in finding value of c. In the beginning only I have told you that restriction will be on c because this is a line with slope m. In fact, there are infinitely many lines having the same slope. All will not be tangent. So restriction will be on c. So we have to solve this equation for c. Now 1a square gets cancelled. So a square m square upon c square plus a square upon c square equal to 1. I have divided both sides by a square. Cross multiply. So c square equal to a square m square plus a square. Take a square common to get in bracket 1 plus m square. I have written instead of m square plus 1, I have written 1 plus m square. So what is c? Yes, plus or minus a into root 1 plus m square. Is that clear? So we have to say that line y equal to mx plus c is tangent to standard circle when c is either plus or minus a into root 1 plus m square. Can I say so? Equation of tangents to standard circle having slope m are y equal to mx plus minus a into root of 1 plus m square. So this is the second part. Now let us discuss third and then fourth part. In third part, we show that in general, two tangents can be drawn to the circle x square plus y square equal to a square from a point x1, y1 in the same plane. Okay. Now this line is always tangent to the circle. If tangent is drawn from x1, y1, it will lie on the tangent. So coordinates will satisfy the equation. I hope this is clear to you. See, y equal to mx plus minus a into is always tangent to this circle. We have just proved this. If tangent is drawn from x1, y1, point x1, y1 will lie on the tangent. So coordinates will satisfy the equation. Now rearrange the terms. So y1 minus mx1 plus minus a root 1 plus m square. Square both the sides. Y1 square minus 2x1 y1 m plus m square x1 square is a square into in bracket 1 plus m square. I open the bracket to get a square plus a square m square. You have to use common sense. When can we say that two tangents? When we get two values of m. Two values of m means our aim should be to obtain a quadratic equation in m. I will write this directly. See, x1 square minus a square m square minus 2x1 y1 m plus y1 square minus a square equal to 0. This is not at all difficult. Bring these two terms to LHS. Take m square common from what? From terms containing m square. Simple. So x1 square minus a square and so on. Now you have to argue that this is a quadratic equation in m. Its two roots are the slopes of the two tangents which may be drawn or can be drawn from x1, y1 to the standard circle. Now why to say may be drawn? Because being a quadratic equation, there are three possibilities of roots. If roots are imaginary, no tangent can be drawn. If roots are real and distinct, yes, two distinct tangents can be drawn. But if roots are real and equal, what happens? Only one tangent can be drawn. So you should be able to say that in that case x1 y1 has to lie on the circle. Then and then only one tangent can be drawn. Is that clear? So this shows that in general two tangents can be drawn to the circle from a point x1 y1 in the same plane. Fourth part, to find the locus of points. Tangents from which to the standard circle are at right angles. Suppose two tangents can be drawn, means roots of this quadratic equation are real and distinct. If tangents are at right angles, what can you say about product of their slopes? -1. But for us, m1, m2 are the roots of this quadratic equation. What is formula for product of roots? Constant term y1 square minus a square upon coefficient of m square. Do you remember that? C upon a. So x1 square minus a square equal to -1. Right? Rearrange the terms. So y1 square minus a square is minus x1 square plus a square. Means what? Means x1 square plus y1 square is 2a square. Note that to get the equation of locus, we replace x1 by x, y1 by y. to get locus as x square plus y square equal to 2a square. Note that this is a circle. Many students think, oh, how can this be a circle? It is not a square, it is 2a square. See, a square means positive real number. 2a square is definitely in that case positive real number if a not equal to 0. So this does represent a circle whose radius is not a, it is root 2 into a. Okay, this circle is called as director circle. So if you are asked what is director circle, you should say that it is the circle tangents from which two standard circle are at right angles. Okay. So what is director circle? Director circle of a given circle is the locus of points P such that tangents from P to the given circle are perpendicular to each other. The equation of the director circle of the circle x square plus y square equal to a square is x square plus y square equal to 2a square. Let P x1 y1 be a point such that the tangents from P to the circle are perpendicular to each other. The equations of tangents in terms of slope m are this: y minus mx equal to, if these pass through x1 y1, I have done exactly the same. Rearrange the terms. This is a quadratic equation in m. The roots m1 m2 of this quadratic equation are the slopes of the tangents that can be drawn to the circle from the point P. Since tangents are at right angles, m1 m2 is minus 1. Yes, see. So the equation of locus is this. This represents a circle whose center is at origin. And what is radius? Root of 2a square, that is root 2 into a. So can I make a statement that what is the radius of director circle? It is root 2 times radius of the given circle, original circle. Is that clear? Okay. Miscellaneous exercise 6. First question. Select the correct option from the given alternatives. First one. Equation of a circle which passes through 3, 6 and touches the axis. They are saying axis means both the axes. So there are 4 possibilities. So you can check for center. If you take as say HH, then radius is also H. So check options for this, or 3, 6 should satisfy the equation. Should satisfy equation. Okay. Tell me the answer. Now in option A, you should be able to find center and radius orally, at least center. So this is center 9 plus 9 minus 3. No, because radius should be 3. So A is not the correct option. What about B? 3, 3, 9 plus 9 plus 9. No, B is not the correct option. Go for C. 3, 3. Okay. Radius is root of 9 plus 9 minus 9. That is 3. Yes. So correct option is C. I know there are many students who cannot find the center and radius. I can't help. See, this is the basic thing. If you do not know how to find the center at this stage, you don't deserve to score marks in exam. I always believe that only deserving candidates should get marks. So C is the answer. Or you could have used this. Check whether x equal to 3, y equal to 6 satisfy the equation or not. You will notice that these coordinates satisfy equation in option C only. Second, if the lines 2x minus 3y equal to 5 and 3x minus 4y equal to 7 are the diameters of a circle of area 154 square unit, then find the equation of the circle. Okay. So we have to consider these options one by one. Basically, Center lies on diameter. What is the center of the first circle? It is 1 minus 1. See whether coordinates satisfy the equation. 2 plus 3, 5. Yes. So can we say that this is the answer? Not yet. Find out radius. Basically area is 154. So pi r square, pi must be taken as 22 by 7, r square is 154. Okay. So what is r square? 154 into 7 by 22. So r square must be 49. Check this. So for the first, what is r? 1 plus 1, 1 plus 1 minus 40. No, no. Okay, what about option B? Check for option B. Center is 1, 1. No, 1, 1 does not satisfy. See, center has to lie on diameter, right? Third, yes, center lies on diameter. And what is radius? It is root of 1 plus 1 minus 47. So plus 47. Yes, 7. So C is the correct option. I hope you are getting this. If not, you can ask me frankly. You can tell me frankly rather. I'll again explain. Third sum. Find the equation of the circle which passes through the points 2, 3, 4, 5 and the center lies on the line y minus 4x plus 3 equal to 0. First check for center lies on this line. See, if center lies on the line, do not conclude that this is the correct answer because infinitely many points lie on this line, right? So there are two options. Suppose you find that circle given in option A, its center lies on the line. Then check for BCD. If circles in options BCD, their centers do not lie on this line, then you can declare that A is the correct option. Otherwise, you check whether these points lie on the circle or not. In this case, option A. You should be able to obtain center orally. What is the center? 2, 5. Does 2, 5 lie on the line y minus 4x plus 3 equal to 0? 5 minus 8 plus 3 equal to 0. Yes. Now don't declare that A is the correct option. See whether 2, 3, 4, 5 lie on the circle or not. Let us check for 2, 3. So x square plus y square means 4 plus 9, 13. 13 minus 8 is 5. 5 minus 5 minus 30 plus 25, 0. Yes. Similarly, check for 4, 5. You will notice that this also lies on the circle. So correct option is A, Ahmedabad for sum number 3. Fourth one, the equation of the tangent to the circle x square plus y square equal to 4, which are parallel to x plus 2y plus 3 equal to 0 are. Basically, parallel lines have the same slopes. So equation will contain x plus 2y, but you will notice that in option B, x plus 2y is there. In option C also, so this will not work. But you should know that tangents with slope m to standard circle are these. Okay. Now how to get m? Slope of the given line is minus half. So slope of tangent is also minus half, parallel lines. What is a? From the circle's equation, a square is 4. So a is 2. Substitute. Simplify. In fact, at this stage only, when you see root 5, you should conclude that C is the option. Why? Because either B or C is the correct option. But in B, it is root 3 and we have got root 5. So no need to simplify further. You can conclude that C is the correct option. Sum number 5. If the lines 3x minus 4y plus 4 equal to 0 and 6x minus 8y minus 7 equal to 0 are tangents to a circle, then find the radius of the circle. Observe that given tangents are parallel to each other, and that is why distance between them is nothing but diameter of the circle. The only thing is this equation to be written by multiplying all the terms by 2. So this is the first This is the second. See, topic is circle, but you should know this formula. Distance between parallel lines. Mod of c minus c dash. So 8 minus minus 7 upon root of a square plus b square. So diameter comes out to be 3 by 2. So what is radius? 3 by 4. It is given in option A. Sum number 6. Area of the circle with center at 1, 2 and passing through 4, 6 is. Now center is 1, 2. This lies on the circle. Every point on the circle is at a distance radius from center. So radius comes out to be 5. What is area? Pi r square. So 25 pi, which is given in option C. Seventh, if a circle passes through the points origin A0 and 0B, then the center is, see, circle passes through origin. So A and B are the intercepts. Angle inscribed in a semicircle is the right angle. As this is a right angle, AB must be the diameter. End points of diameter are known. Center is midpoint of diameter. Use midpoint formula. So correct option is D. Sum number 10 will be doing 8, 9 after 10th. The parametric equation of the circle x square plus y square plus mx plus my equal to 0 are. See, what is the center hk of the circle? Minus m by 2 minus m by 2. What are the parametric equations? See, you should know all standard results. X equal to h plus r cos, y equal to k plus r sine. So x is minus m by 2 plus y is also minus m by 2 plus. This part is present in option A only. So A is the correct option. Now you should ask me, sir, if these are present in remaining options, then what? Then of course you have to find radius r. You will notice that radius comes out to be m by root 2. So r cos means m by root 2 cos and r sine means m by root 2 sine. But at least in this sum it is not required. So correct option is E. Sum number 8. The equation of a circle with origin as center and passing through the vertices of an equilateral triangle whose median is of length 3a. Now listen to me carefully. This is the triangle. Let PM be the median of the equilateral triangle whose length is 3a. Now you should know that circumcenter and centroid of the triangle coincide, and you should know this property also. Centroid divides the median in the ratio 2:1. Okay. Now total is 3a. Total is 3a. But this divides in the ratio 2:1. Okay. So radius must be 2/3 of 3a, which is nothing but 2a. Because origin happens to be the, in fact, it is what? It is not only centroid, but it is circumcenter also, right? And therefore this OP is 2/3 of 3a. That is nothing but 2a. Now center of the circle is at origin and radius is 2a. So what is the equation? X square plus y square equal to 4a square. Let me explain first. So this is for sum number 8. C is the correct option. Don't write. Now ninth is also interesting. A pair of tangents are drawn to a unit circle with center at origin, and these tangents intersect at A, enclosing an angle of 60 degrees. The area enclosed by these tangents and the arc of the circle is, see, major angle POQ. In this case is 2 pi upon 3. I hope you understood this. Still I'll explain. This is 60, so this is 30, this is 30. Now radius through point of contact is perpendicular to tangent, so this is 90. So this has to be 60. Similarly, this is 60, so 120. Now in right angle triangle OPA, what is tan 60? AP upon OP. So AP is nothing but OP tan 60. Now this is unit circle, so OP is 1, so root 3. So we can get area of triangle OAP, which is root 3. So what is area of this quadrilateral? Root 3 plus, in fact, this is root 3 by 2, area of triangle OAP. So total area Root 3 by 2 plus root 3 by 2, that is root 3. So what is required area? Root 3 minus pi by 3. Now you will ask me, sir, why this area is pi by 3? Because what is the formula for area of sector? Half r square theta, right? R is 1, theta is 120 degrees. Angle must be expressed in radian only. So pi by 3. So correct option is B, Bombay.